Okay, y'all, we started the year and we talked about end behavior. Well, we talked about a bunch of stuff with graphs, but one of the things we talked about was end behavior. So if I was talking about the end behavior of this graph as x approaches negative infinity. So as x went to negative infinity, what was happening to my y? As I went negative infinity, what's happening to y? Is it getting bigger, smaller? What's happening to it? It's getting bigger, right? This is getting bigger and it's going up, so it's going to positive infinity. You see that? Okay. So as x is going to positive infinity, so as x is going to positive infinity, what's happening to my y values? They're going to negative infinity. So that's our end behavior. That was what was happening at the very end of our functions. So today what we're going to do is we're going to talk about limits. And that's going to be the concept of a function approaching a certain value. The concept of a function approaching a certain value. And this is how we write it. The limit as x goes to c of f of x is going to equal a limit. It's going to equal a number or maybe a define, but it's going to approach something. So let's start with 2, 3, and 4. Let's write our end behavior as limits, and then we'll talk about limits. So the first one, the limit as x approaches negative infinity, the limit as x approaches negative infinity. So as I go to negative infinity, what's happening to my y value? Is it getting bigger or smaller? Smaller, so it's going to negative infinity. And the limit as x approaches positive infinity, so my x's are getting bigger, what's happening to my y values? They're also getting smaller. So yeah, this is negative infinity and positive infinity, and y'all, this part is going to be the same every time. We're going to do the limit as x goes to negative infinity, and the limit as x goes to a positive infinity. So the limit as x is going to negative infinity this time, what's happening to my y value? It's going to negative infinity. And as x goes to a positive infinity, what's happening to my y values? It's getting bigger, so it's going. So look, in the first one, they both went negative. In this one, one went positive and one went negative. Okay? And in the last one, the limit as x goes to negative infinity. So as x goes to negative infinity, what's happening to the y value? It's getting bigger, so it's going to infinity. Now this time, the limit as x goes to a positive infinity, y'all, what value is y going to? Negative what? Does it keep going down? What does it go to? Negative 4. So this was a positive infinity and a number, okay? So you get all different kinds of things that it can approach. Okay. So limits at a certain value. So what if C is a certain value? If C is a certain value, so it's always going to be my X value, right? So where is X on my graph? I want to know what's happening at the Y value, all right? So the limit is the value in which X is approaching from either side of C. So when it's coming from either side of C, it's important to understand that a limit is not what happens at C, but what happens before or after it, okay? So here's what I'm going to just tell you. I'm going to tell you that, like, give you an example to help you think of this, okay? So, is anybody playing football in here? No? All right, you'll have to be me. All right, I'm playing football, right? And I've got the football, and I am running towards the end zone. I'm at the 40, I'm at the 30, I'm on TV, everybody is screaming because they want to see the big fat guys splat me, right? But I'm so fast they can't catch me. I am running, I'm at the 20, I'm at the 10. Now, all of a sudden, the power goes out in your house. So we're all screaming at the TV, right? Because you want to watch me make the touchdown. I want to be the winner. So the power is off for a little while, but then when it comes back on, the other team has the ball, and my team went up by 7 points. So what happened while the power was out? What did I do? I scored, right? But you didn't see it, but you still know I scored, correct? Limits are going to work the same way. I don't care what happens at the moment of my touchdown. You didn't see it, but you're going to know I made the touchdown. So we don't care what the limit is right here. We're going to look here and here. We're going to look on either side. Because a lot of times it's going to be undefined. We don't care that it's undefined at that point. I want to know what is it just before and just after. Does that, y'all understand what I'm trying to say here? Okay, so. All right, so look. So this is the graph. This is the graph of the table that y'all have. Do y'all see the table? Okay, so look. I want to know the limit as x approaches 2. Okay? So the limit as x approaches 2. So if I put the cursor on here, what's my x value now? 3. So I want to go to 2. Let me get my big fat hand out of the way. Okay, so at 2, what is the value? Can you see? Negative 0.75. So on either side, though, do you see it's negative 0.7 on both sides? Right? They match. Okay? So the limit here is going to be, for the first one, is going to be negative 0.75. So this is negative 0.75. Okay, so the next one is this one. So where am I going to look for the limit? At x equals what? All right, so I'm going to find x equals 4. So at x equals 4, what's the y value? 10. So the limit there is 10. Okay, so this one, I'm looking for the limit at negative 1. So what's the limit at negative 1? Negative 3. Is that your next one? Okay, so we want the limit at negative 3. So what is the limit at negative 3? Do I care about that? No, I want to look on either side. So just before negative 3, what am I getting? Like negative 4.4, and just after, negative 4.5. So it's either negative 4.4 or negative 4.5. Either one would be fine. Okay, so I want the limit at 0. So what's the limit at 0? I can't get it exact here. Well, so it's like 0.5. Oh, there's at 0, it's undefined. We don't care that it's undefined. On either side, it's 0.5. So y'all, this is exactly what limits are for. So I'm finding the limit as x goes to 1. So if I put 1 in here, what's the square root of 1? And 1 minus 1 is 0. Can we do anything if we divide by 0? No. So that's why we do limits. I know it's 0 right there. I know it's undefined, but I want to know what's happening around it. So here I want to know the limit as x goes to 1. So we just said at 1 it's undefined. So on either side, it's almost, so it's 2 on both sides. Okay, so for this one at x equals 3, so at x equals 3, it's undefined, right? But on either side, it's almost negative 1. There's going to be 3 examples I'm going to give you where the limit does not exist, where we're going to put D and E, does not exist. These, where it says fail to exist, we're going to do does not exist. No. I'd have to give you a calculator. You have to type it in. Take us hours. Okay. So on the first example, where limits do not exist, so I'm finding the limit at 0. So take your finger and find 0 on your graph. What's happening at 0? It's a jump right here, okay? So remember we said we're going to look at it from the left and from the right, correct? So all of the examples I gave, the number from the left and the right matched, right? But here at 0, do the numbers match from the left and the right? They don't, so the limit cannot exist. So when there's a jump, it does not exist. So at this asymptote, it says that a vertical asymptote limits can exist. Well, here's why it doesn't exist here. If this is my limit right here at negative 2, from this side, it goes to negative infinity, right? What does it go from this side? Positive infinity. Do they match? If they don't match, it can't be a limit. So this does not exist because the limits are different. Does that make sense? Y'all get this? You're all tired?
But I don't want to get the explanations, but if we just know that it's a jump, vertical asymptote, or the other one where it's not going to be.
Correct. That's going to happen. So here, y'all, what's happening at 0 is this is called oscillation, and this doesn't exist. You can't have a limit when it's doing this. Okay? All right. Okay, so let's look at the limits. Okay, so I want the limit as x goes to negative 1. So first of all, here's negative 1. What's happening? Can I have a limit? So it does not exist.
So I'm going to take a picture of how you did that.
I'm gonna, y'all, I have, my last class, I gave a code. I have a code. All of these we do, I'm gonna give you a code and they're already typed in. But, some, they're messed up, so I'm gonna fix them at lunch. You'll always have a code, you'll be able to see them, okay? And on your test, I'm gonna have them typed in already for you. But I don't know, from last year, I don't know if we changed the worksheet, but they don't match. But they will match the next time, okay? All right. So, this is my next one. Is that your next? Yes. So I want the limit as x goes to 2. So the limit as x goes to 2. So first of all, here's my 2. Is there a jump, an asymptote, oscillation? No. Is the number going to be the same coming from both sides? Yes. So even though it's undefined right here, it's going to be the same coming this way. It's at 6, and coming this way, it's at 6. So both sides, so the limit there would be 6. Okay, so the limit at 3. So I want the limit at 3. So at 3. Okay, so here's my limit at 3, all right here. Let me see if I can get my hand out of the way. So it says it's undefined, but here on this side is negative 1.1, and here on this side, it's like negative 1.2. So negative 1.1 or 1.2 would be fine. Okay, so this one, I'm finding the limit at what? 1. And what's happening at 1? Why? There's a vertical asymptote. This one goes up, this one goes down. They don't match, so it doesn't exist. So the limit as x equals 1. So here's x equals 1. It's undefined there. So on this side, I'm getting 0.1, and on this side, I'm getting 0.9, so 0.1. So at negative 1, what's happening? Jump, is there a limit? Nope, no limit at a jump. So at x equals 3, so at 3 it's undefined, so I have negative 6 and negative 5.9, so I'm going to get negative 6, because they matched. So this one, we want the limit at x equals negative 4. At negative 4, it makes a 0 on the bottom, so it's undefined, but what's happening at negative 4? Jump, so it doesn't exist. So next I have the limit as x goes to 0, the cosine of 1 over x. What's happening here? Oscillation, so it doesn't exist. So at 0, I get a negative pi over 4. So that's your limit. Am I on the right one? Yep. Okay. So we have, we're going to do pi over 2. I know it's a pi over 3, but what's the limit at pi over 2? 0.
So for these ones, when it's like pi over 2, use that our Precal circle.
You're going to be able to see it on here. Okay, I'm going to fix it so that's what it says. What's happening at 0, friends? So is there a limit? No. At tangent, it wants to know at pi over 2. So here's my pi over 2 right here. And so what's at pi over 2? And 1 goes up and 1 goes down. Is there a limit? No. Okay, here's the cosecant. I want the limit at pi. So pi over 2 wants to know the limit at pi over 2, which is right here. And what's the limit? 1. Oh, wait, it wants it at pi. Sorry, guys. Here's pi. 1 goes up, 1 goes down, so it doesn't exist. All right, here's the next one. I want to know the limit at 0. I want to know the limit at 0. So it's a vertical asymptote, but are these going the same way? They are. So what's my limit? Negative infinity. And the same thing here. I want to know the limit at 0. And they're both going up, so this one would be infinity.